Sample problem 18.5. According to table 18.4, a reaction will be spontaneous only at high temperatures if both delta H and delta S are positive. For a reaction in which delta H is 199.5 kilojoules per mole, so that's positive, and delta S is 476 joules per Kelvin mole, that's also positive, determine the temperature in degrees Celsius above which the reaction is spontaneous. So the idea here is this. If delta G, the change in free energy, if delta G is negative, less than 0, we would say that it's a spontaneous process at that temperature. If delta G is greater than 0, it's a non-spontaneous process at that temperature. Okay? So really what we're doing is we're saying this. Delta G is delta H of the system minus T delta S of the system. Okay? So what we're going to do is we're going to plug in delta H and delta S. We know those. And we're going to set delta G equal to 0, meaning above a given temperature T, delta G will be negative, but below that temperature it'll be positive. Okay? So if you think about it, if these are both positive here, this is positive, it would be positive minus a positive times a positive. So what we're saying is, if delta G equals 0, that's the temperature where it just becomes spontaneous. We'll set that equal to delta H minus T delta S. And then I'm going to add T delta S to both sides. Well, minus T delta S and plus T delta S is 0. So that means delta H is equal to T delta S. So let's divide both sides by by delta S. And now you get T equals delta H over delta S. So here's the logic. What you do is you do that ratio. You take delta H, which is given, and you divide that by delta S, which is given. And once you do that ratio, that will tell you what temperature above that it's spontaneous, and then below it, it wouldn't be spontaneous. The issue here, however, is a couple details. One is the units are not set up properly. We have kilojoules in the numerator and joules in the denominator, so that's got to be resolved. So here's what I'm going to do. I'm going to multiply this by 1,000 joules per kilojoule. That'll get rid of our kilojoules there. So now we have 199 times 1,000. So that's 199.5 times 1,000. I'll just write it times 10 to the 3. And then that would be joules per mole. Divide that by 476 joules per kmol. And then that'll give you your temperature. Okay? Joules cancel, moles cancel, 1 over Kelvin. That equals Kelvin. So you're going to get an answer here in Kelvin. So it's 199.5 times 10 to the 3. So let's see if this calculator can do that. 199.5 times 10 to the 3. There we go. Divide that by 476, and you get 419. So what that means is, if the temperature is greater than 419 Kelvin, delta G is negative, and it's spontaneous. You can look at that, right? Put in 420. Put in 420 into this calculation, into that number there, and you'll get a negative value over there. Anything greater than 419. Put in 418, that's less than 419, and you'll get a positive over here, meaning non-spontaneous. Okay? Now, the one thing they say is put it in Celsius. So if we want it in degrees Celsius, we take 419 and we subtract 273. And so what does that come out to? 119, 129, 139, 149. Looks like 146, but let's go ahead and try it. 419 minus 273, 146. Okay, that would be Celsius. Okay, so it is spontaneous, but only if the temperature is greater than 146. If it's right at 146, it's right on the cusp of being spontaneous. It's reversible. And then if it's below 146 Celsius, it would be non-spontaneous. Okay. Again, you can just put numbers in and see what sign you get for delta G.